Matter and its properties. Everything in the universe is made of matter, which has both mass and volume. For a long time, there were two main ideas about matter. One that it was continuous like a block of wood, and another that it was made of particles like sand. Modern science supports the idea that matter is made up of tiny particles. Physical nature of matter. Matter is made up of particles that have space between them. When you dissolve salt in water, for example, the salt particles get into the spaces between the water particles, which is why the water level doesn't change. The particles of matter are also continuously moving and have kinetic energy. As temperature increases, the particles move faster, and their kinetic energy increases. The intermixing of particles of two different types of matter on their own is called diffusion. Diffusion gets faster when you heat the substances. Particles of matter also attract each other with a force that keeps them together, and the strength of this force varies depending on the type of matter. States of matter. Matter exists in three main states: solid, liquid, and gas. The differences between these states are due to the characteristics of their particles. Solid state. Solids have a definite shape, distinct boundaries, and a fixed volume. They are rigid and have negligible compressibility. The particles are tightly packed and held together with maximum force. Liquid state. Liquids have no fixed shape but do have a fixed volume. They take the shape of their container and are considered fluid because they can flow and change shape. Particles in a liquid move more freely than in a solid and have greater spaces between them. Solids and gases can diffuse into liquids. Gaseous state. Gases are highly compressible compared to solids and liquids. They have no fixed shape or volume and fill the entire container they are in. Gas particles move randomly at high speed and have the largest spaces between them. They diffuse very quickly into other gases due to the high speed and large space between their particles. Change of state. The state of matter can be changed by altering the temperature or pressure. Melting fusion. When a solid is heated, its particles gain kinetic energy and start vibrating faster. The heat energy overcomes the forces of attraction, causing the solid to melt into a liquid. The temperature at which this happens is the melting point. During melting, the temperature remains constant because the heat supplied is used to change the state of the substance, known as the latent heat of fusion. The latent heat of fusion is the amount of heat energy required to change 1 kilogram of a solid to a liquid at its melting point. Boiling vaporization. When a liquid is heated, its particles move even faster. At the boiling point, particles have enough energy to break free from the forces of attraction and change into a gas. This is a bulk phenomenon, meaning particles from the entire liquid change into the vapor state. Similar to melting, the temperature remains constant at the boiling point due to the absorption of latent heat of vaporization, sublimation, and deposition. Some substances, like camphor, can change directly from a solid to a gas without becoming a liquid. This process is called sublimation. The reverse process, where a gas changes directly to a solid, is called deposition. Effect of pressure. Increasing pressure can bring particles of matter closer together and can liquefy gases, especially when combined with a decrease in temperature. This is why gases like LPG and CNG are stored in compressed cylinders. Solid carbon dioxide, CO2, is a good example of this. It turns directly into gas when pressure is decreased, earning it the name dry ice. Evaporation and cooling. Evaporation is a surface phenomenon where a liquid changes into a vapor at any temperature below its boiling point. Particles at the surface with higher kinetic energy overcome the forces of attraction and become a vapor. The rate of evaporation increases with an increase in surface area, for example, spreading out clothes to dry, an increase in temperature, a decrease in humidity, the amount of water vapor in the air, an increase in wind speed. Evaporation causes cooling because the liquid particles absorb energy from their surroundings to regain the energy they lose during the process. This absorption of energy makes the surroundings feel cool. This is why your palm feels cold when you put acetone on it, and why we wear cotton clothes in the summer to absorb sweat and allow it to evaporate, which cools the body.